Welcome back to Forward CloudSec. This is Stop Guessing and Start Proving, Demystifying AWS Zelkova with Kaushik Devireddy. Before he starts, I'd like to thank our sponsor, Wiz. Wiz secures organizations that build and run in the cloud. Wiz enables hundreds of organizations to rapidly identify and remove critical risks in cloud environments. Thank you, Wiz. Over to you, Kaushik.
Thanks. Good to see you all. Today, we'll be demystifying AWS Zelkova. Before we do that, I want to go ahead and introduce myself. A little about me. I'm an undergraduate at UCLA studying computer science, working on formal methods and automated reasoning. And I also work part-time at Dasana as an engineer building a security data lake where we ingest all your cloud security logs, assets, and vulnerabilities. So flashback to 2019, I was scrolling YouTube and came across this recommended video. It was AWS Reinforce 2019. The talk was titled The Evolution of Automated Reasoning Technology. Now, I kind of got hooked by the central question in this video, which was, can we use math to prove that our policy permissions are correct? Notice that the word correct is in quotes. This will be important. We'll come back to this later. But back in 2019, I was a high school senior. I knew very little about AWS and even less about cloud security, and I certainly didn't know anything about automated reasoning, proving policies, or SMT solvers. But I saw these complicated diagrams and cool math formulas, and actually the person in that picture, Neha, she used to be a research scientist at NASA, so I was super impressed by their work. I thought finally, we had found a silver bullet for security, a way we could verify everything. And already you guys are laughing, and after 3 years I learned that no, there is no silver bullet for security, and Zelkova is no exception. So with that being said, I want to jump quickly into how provable security works, dive into the internals of Zelkova, and then talk about my experience operationalizing a provable security tool at a UCLA research lab, and then from that experience, what I learned, what provable security was missing. So provable security in AWS kind of split into two domains, networking and IAM. There were two kind of seminal papers on this topic, and out of these papers came the services Tiros and Zelkova. Today, we're only going to be focusing on the IAM side, so that's Zelkova. And if the name doesn't seem super familiar to you, it's because you won't find it in your console. Never made it out of GA. But there are some products built on top of it, so it's important to understand how Zelkova works. Before we can verify policies, we unfortunately have to do the tedious work of understanding what a policy is. So kind of in English, if I had to explain this policy, I would say that it would allow any action of get object and put object on any S3 bucket in your account. Now, if I wanted to kind of explain this in a more logical way, using ands and ors, the way I'd encode this policy is by saying, allow if the action is S3 get object or S3 put object. Notice the or, and that's kind of a logical construct that we'll be using going forward. We can do the same thing with ands. In this policy, what we're saying is allow S3 get object if the resource that we're applying this performing this action on is this bucket, and it's coming from this principal. So again, we can kind of encode this in a logical way. Allow if it's this action, and this resource, and this principal. So now let's put it all together, these ors and ands. Let's look at a kind of a bigger policy and try and encode this one. So this policy is saying that allow if the action is either get object or put object, and it's this resource, and it's one of these two principles. So congrats, you've learned how Zelkova actually internally encodes their policies. And they do it on a bunch of different condition keys, and it's a little more complicated than what I showed you today. But the basic idea is we want to take a JSON IAM policy and turn it into a series of and or statements. So at a high-level overview, what Zelkova does is what we just looked at, taking these policies and turning it into logical models, the ands and ors. And then it takes those models and passes it to what's called an SMT solver. We'll get into this in a little bit. And then tells us whether the policy is more permissive, equivalent, or less permissive. And then we have two cases for exceptions, which we'll also get into. So all of this is kind of abstracted away from you. You just have to call the Zelkova library. Remember, it's not really an API. You can think of it more as like a Python library. It's stateless. You just give it two different JSONs, two different policies. You might be wondering, why are there two policies? We want to verify one policy. Why do we have to tell it two? Zelkova has this notion of what's called a probe policy. So the first argument to Zelkova is the policy that you've written and you want to verify. And the second is the probe policy. This is like the specification you want to use to verify the proposed policy. An example of a probe policy would be, this principal should only have read-only access to S3. So an example of a proposed and probe policy would be like this. On the right-hand side, the probe policy, you can see, enumerates all the different read-only actions for S3. And a proposed policy that I've written is just simply allowing get object. So if we pass this to Zelkova, Zelkova would look at what are the actions allowed by the proposed and probe policy, and compare and try to figure out which one is more permissive. So in this case, Zelkova would tell us that the proposed policy is less permissive than the probe policy. So it's great. That means our proposed policy fits within our specification. We can go ahead and use it. Now in this example, I've modified the proposed policy to allow put objects. Now remember, our specification said we should only allow read-only access. So Zelkova will look at this and say, no, the proposed policy is actually more permissive than the probe policy. So we've kind of done this visually, like looking at these different actions and comparing them. But the way Zelkova is like a computer. It can't do this kind of visual kind of matching. So what it does is it uses an SMT solver. And it sounds fancy, and I thought it was super fancy, but it's actually really simple. You can tell by this example. If I gave you the formula x plus y equals 5 and asked you to tell me what could x and y be, an SMT solver might tell me 2 or 3. X is 2, y is 3. Note that it doesn't tell me all the possible solutions, just one solution. Another example, kind of similar to our ands and ors example, would be x and y are not z. An SMT solver would say x could be true, y could be true, and z could be false. And this satisfies our expression, hence the word S in SMT, satisfiability. So the way Zelkova works is it takes our proposed policy and probe policy and tries to figure out, is there any action in our proposed policy that is satisfiable but not allowed in our probe policy? And from the example before, we saw that put object would satisfy the proposed policy but not the probe policy. So the SMT solver would return this to us. So you might be thinking, awesome, let's just go verify everything in my AWS account. I'll never get breached again. But not so fast. Remember this question I asked you, can we use math to prove that our policy permissions are correct? And herein lies, I think, the biggest flaw with Zelkova, which is that telling Zelkova what is correct is actually really hard. Telling Zelkova what correct means I might have to write hundreds or thousands of probe policies, many of which are custom to my infrastructure, and I can't just share it with you or post it on like an open source repo for other people to use. So, and the reason is that Zelkova's idea of relative permissiveness, having two different policies that I have to compare, is essentially just pushing all the work from verifying to specifying what's correct. So in the past, verifying properties of a policy might have been hard, but today with Zelkova, all the real work is now specifying what is correct. And in a lot of cases, this doesn't really help you save any time. So you might be thinking like, oh, was learning all of this for waste? Fortunately, there are some specifications which are true across many organizations and resources, one of which you'll all be familiar with, which is the idea of denying public access. So this is a probe policy for trust policies for IAM, which says that only allow people to use this role from this specific principal, which is my own account ID. So what this is saying is, if I create a policy which allows a third-party access, say I allow Wiz to access my infrastructure, the probe policy would not allow this. Congrats. This one single policy actually just built AWS Access Analyzer. So AWS Access Analyzer is built on top of Zelkova. I'm not talking about the least privileged part of Access Analyzer where it tells you these are the permissions you're not using. I'm talking more about the public access findings of Access Analyzer. So now I want to talk about my experience kind of operationalizing provable security and using Access Analyzer at one of the research labs at UCLA. So kind of the backstory is that there was a bunch of hardware and mechanical engineering labs at UCLA, and they all wanted to use AWS, but they wanted the school to pay for it, obviously. So the school said, great, we'll give you all this money, but we're kind of scared that we don't have any oversight into this. So they decided to hire some software engineers to help them out, and I ended up taking the role of helping them out to do this. So Access Analyzer essentially is this idea that you can create a zone of trust for all the resources in your account, which is the account boundary. And if there's anything which can access these resources from outside your account, like for example, if you created a role with a trust policy to allow Wiz to access your account, Access Analyzer would kind of flag the resources that are allowed to be accessed from outside your account. Again, we do this through this kind of probe policy that we talked about before. So these are the accounts that would be flagged by Access Analyzer. So this is like Access Analyzer's dashboard, and this is the first thing I looked at when I inherited all the AWS accounts for these different labs. And you'll see like one of them is a tenable role, so I like to say Access Analyzer can double as a vendor list. You can find all the different vendors in your account. Maybe you'll find some vendors you aren't using anymore, you can kick them out. So the way that we ended up using Access Analyzer is rather not through the dashboard, but through the API. So a lot of people were deploying things to Terraform, so we allowed people to check Terraform into a Git repo. We had a GitHub action that would call create access preview for Access Analyzer. What this would do is before you actually deployed the resource, it would check, would this create any sort of public access? And if Access Analyzer told us no, then we would deploy it to AWS. Now, you might have seen in the description of this talk, I talked about, is there any instances where Zelkova might time out? And so I started messing around with this. And if you start actually adding a lot of wildcards and like clean stars in different roles and different probe policies, Access Analyzer would take longer and longer and longer to analyze. And there was one instance where it returned, it basically said it was unable to evaluate the policy, and it timed out. So this is kind of not realistic. This is more, if you're interested, you could try this out. So one of the big problems and flaws I found with Access Analyzer is kind of in the following scenario. Let's say we have a role outside of our account which can assume a role inside of our account. And then we have role chaining in our account to a specific resource. Now, if I asked any one of you, like security practitioners, you guys would say all of these are at risk for third-party access. One role outside of the account can access all of these different resources. Unfortunately, Access Analyzer only tells me that the leftmost role, the first kind of point of contact for this third party, allows public access. This kind of makes no sense to me. Why are we using formal methods in Zelkova if we're only showing like one possibility? The whole point of formal methods is to show the entire picture, find all different possibilities. So this, I think, there's a talk after this by Mohit and Nick, and they're kind of building a solution on top of formal methods to kind of address this problem. So I encourage you guys to stay for that. So this kind of segues into what I think provable security is missing, and the biggest thing is context. Again, today we've all talked about IAM, but look at this following scenario where we have an EC2 instance that has an attached role to get data from S3. This EC2 instance is open to the world. Security group allows everything. I would say that this S3 bucket should be classified as at least some sort of risk, maybe not public access, but you should say that it's kind of reachable from the internet. If we just use Zelkova, we won't be able to find out, or Access Analyzer, we won't be able to find out that this S3 bucket is at risk. We need to find a way to blend formal methods from networking and identity and blend them together to get the full picture. And the problem that I ran into at UCLA was this idea of missing workload context. Remember, Access Analyzer lets you define the zone of trust of accounts or organizations. But within accounts, one lab in particular was a genomics lab. They wanted to isolate kind of these genomics workloads and data stores from the rest of the things in the account. Obviously, as security practitioners, we might want to say split it into different accounts, but these guys had already loaded all their resources in there, and I came in after. What I would have wanted to do is been able to use something like Access Analyzer to check if different isolations of tags existed. So for example, all the things tagged PCI were isolated from other resources. Again, Zelkova, in theory, would allow you to do this, but the way that it's packaged to consumers today through Access Analyzer and other products doesn't allow you to do this. So kind of my conclusion is that formal methods are very powerful, but in a very small niche. Again, we talked about the problem of verifying things is not really easy, but specifying what's correct is really hard. And now with products like Access Analyzer, we don't have access to the full API of Zelkova unless you're a huge organization like Netflix or Bridgewater. If you do want access to Zelkova, it never really made it out of GA. I don't think it ever will, but we can chat after. I have some backdoors. And Yeah, so I think I encourage all of you to start using Access Analyzer and enable it for your organization, but be prudent about the fact that it's not really showing you everything that's wrong in your organization. So I'd like to thank Professor Varghese and Professor Kleinrock from UCLA, as well as the entire Dasana team for helping with this talk. And thank you, guys.
Thank you, Kaushik. Are there any questions in the room?
Thanks, I really enjoyed your presentation. Did you have a chance to look at Zelkova's role in evaluating policies for, I call it borking access, creating a policy that would lock you out of a resource? Did you happen to look at Zelkova's role in that decision-making process?
So you're talking about something like, say I make a policy for S3 where the source VPC I don't have, and then it locks me out because the console goes to the source.
Correct.
I personally haven't seen that use case, but Zelkova definitely could help there. We could write a probe policy which says, like, if you create a source VPC, it must exist in your account.
Other questions in the room?
So I saw role chaining was a thing there.
Mm-hmm.
I saw role chaining was a thing, but doesn't Amazon have a service that like blocks role chaining? And could you check for that instead? It's like not a service, it's like the external ID. And that allows like one-to-one, and it doesn't allow hops.
Right, yeah, I think, I would need to get back to you on that, but I think the case where I came across, there was, external ID was optional, and I guess I should try that out. But yeah, that would be a good idea.
Yeah, it seemed like it'd be a simple check.
I agree, 100%.
I was going to say for external ID, they only enforce that if you're like an outside service coming in. So once you're in, you can just go wild. For your graph, when you say like, yeah, we loaded all our apps into one account, can Zelkova take like say cluster or whatever tagged on that? Let's look at the policies attached to see where it goes to that resource. Because would that solve the kind of, I'm looking at this workload, I want to see where it goes?
Yeah, that's what I would ideally want Zelkova to do. But the problem is Zelkova is kind of stateless. It doesn't pull in these information of these are the tags it has, et cetera. And so, again, I think Mohit and Nick are working on a tool that will allow you to add this kind of context and data around what the resource is and where it is.
Any other questions in the room?
Awesome talk, thank you. Can we expand this to other use cases like security group rules or anything else?
So, yeah, that's a great question, actually. Let me jump to one of the first slides I had. So, AWS actually has a really nice service for this called Tiros. And so they do kind of formal methods for networking. This Tiros powers like VPC reachability analyzer, like those different tools. So they can do things like, find a path through security groups, through all the route table hops, through and into an instance. So I don't believe that Tiros, doing that, I think you're asking about doing a similar query for networking. I think Tiros has a similar story to Zelkova, where if you're not a big organization, you can't really get access to the Tiros API. Did I answer your question?
Yeah, just like in general, can we apply similar principle?
Oh, yeah, for sure. So there's this whole field called network verification. It's kind of been super academic, but there are some companies who are trying to take those principles, like Forward Networks is one that was born out of this research of formal methods for networking. So if you're curious, search up header space analysis. It's kind of like doing SMT solving for policies, but in a much more efficient way for networking.
Thank you.
Any other questions?
Oh, should I pull it up?
Sorry, you don't need to.
Okay.
How do you get that information about Zelkova if it's an internal AWS tool?
So So yeah, I'll DM Christoph. I know him. Yeah.
So we'll take it offline, Christoph.
But yeah, so like I said, if you're a big enterprise, reach out to your TAM, and you'll need a lot of approvals. But I think if you really want access to Zelkova, you can get it. But like I said, there are alternatives coming out, which I think can be more powerful. Again, stay for the talk after. I'll be here. I'm really excited for that.
And I don't know if you had a slide about your contact information.
Oh,
If there's anything to share.
yeah, it's my first name at dasana.io.
Right, any other questions? Thank you, Kaushik.
Yeah.
10-minute break.